In this video, we are going to see about discrete time Fourier transform of elementary signals. We know the discrete time Fourier transform of a discrete time signal x of n. It is given by x of e power j omega, which is equal to summation n equal to minus infinity to infinity x of n into e power minus j omega n. Here we are going to see the discrete time Fourier transform of some of the elementary signals. Here we are going to find the discrete time Fourier transform of a impulse signal which is shifted by the time period n0. We know that the discrete time Fourier transform is given by x of e power j omega, which is equal to summation n equal to minus infinity to infinity x of n into e power minus j omega n. Here the input x of n, it is equal to del of n minus n0. That is, unit impulse is shifted by n0. We know that the unit impulse sequence del of n is equal to 1 when n equal to 0. Here del of n is shifted by n0. So at n equal to n0, that del of n minus n0 is equal to 1. We know that the unit impulse sequence del of n, it is equal to 1 when n is equal to 0. Here del of n is shifted by n0. So at n equal to n0, del of n minus n0 is equal to 1. Therefore, x of e power j omega is equal to del of 0 at, that is at n is equal to n0, del of 0, e power minus j omega at n is equal to n0, we will get this. We know that del of 0 is equal to 1. So, x of e power j omega is equal to e power minus j omega n0. So, discrete time Fourier transform of unit impulse sequence shifted by n0 units, which is equal to e power minus j omega into n0. Similarly, del of n minus 1, when you are taking discrete time Fourier transform, it is equal to e power minus j omega. Discrete time Fourier transform of del of n minus 2 is equal to e power minus j 2 omega. If it is discrete time Fourier transform of del of n plus 1, it is equal to e power j omega. Discrete time Fourier transform of del of n plus 2, it is equal to e power j 2 omega. Here we are going to find the discrete time Fourier transform of the unit step sequence shifted by n0 units. We know the discrete time Fourier transform of a signal x of n, it is given by x of e power j omega, which is equal to summation n equal to minus infinity to infinity x of n multiplied by e power minus j omega n. Here x of n is equal to u of n minus n0. We know that unit step sequence u of n, which is equal to 1 when n is greater than or equal to 0. Here the unit step sequence is shifted by n0 units. So u of n minus n0, it is equal to 1 when n is greater than or equal to n0. So it is enough to consider n equal to n0 to infinity. At that duration of n minus n0 is equal to 1 multiplied by e power minus j omega n. When you are expanding this summation, when n equal to n0, term becomes e power minus j omega n0. Next value is n0 plus 1. So e power minus j omega n0 plus 1. Next value is n0 plus 2. That is e power minus j omega n0 plus 2. Likewise it will be going on. When you are taking e power minus j omega n0 outside, it becomes 1 plus e power minus j omega, e power minus j 2 omega, e power minus j 3 omega likewise. This is equal to 1 plus x square plus x cube plus etc. up to infinity. This is equal to 1 by 1 minus x. This is similar to 1 plus x square plus x cube etc. up to infinity, which is equal to 1 by 1 minus x. This can be rewritten as e power minus j omega n0 divided by 1 minus e power minus j omega. So the discrete time Fourier transform of unit step sequence shifted by n0 units, which is equal to e power minus j omega n0 divided by 1 minus e power minus j omega. Similarly, u of n shifted by 1 unit, when you are taking discrete time Fourier transform, it is equal to e power minus j omega divided by 1 minus e power minus j omega. Now we will find the discrete time Fourier transform of the sequence a power n into unit step sequence. We know that discrete time Fourier transform of a signal x of n, it is given by x of e power j omega. Here x of n is equal to a power n into u of n. We know that unit step sequence value is equal to 1 when n is greater than or equal to 0. So the equation can be rewritten as n equal to 0 to infinity, a power n into e power minus j omega n, which is equal to summation n equal to 0 to infinity. We can combine these two terms, a into e power minus j omega the whole power n. Expanding the summation, n equal to 0, it will be equal to 1. When n is equal to 1, a into e power minus j omega. When n is equal to a into e power minus j omega the whole square. Likewise, it will be going on. We know that 1 plus x square plus x cube etc. up to infinity, which is equal to 1 by 1 minus x. So we can rewrite this expression as 1 by 1 minus a into e power minus j omega. So the discrete time Fourier transform of a power n multiplied by unit step sequence, which is equal to 1 by 1 minus a into e power minus j omega, or it is equal to e power j omega divided by e power j omega minus. Now we will find the discrete time Fourier transform of sequence minus a power n into u of minus n minus 1. We know that the discrete time Fourier transform of a signal x of n is given by x of e power j omega. Here x of n is equal to minus a power n u of minus n minus 1. We know that u of minus n, it is the time reverse version of unit step sequence. This u of minus n minus 1 will be equal to 1 when n is ranging from minus infinity to minus 1. This is equal to summation n equal to minus infinity to minus 1 minus a power n multiplied by e power minus j omega n. We can rewrite this summation as n equal to 1 to infinity instead of minus infinity to minus 1 by changing the n value inside, that is a power minus n e power j omega n, which is equal to minus summation n equal to 1 to infinity. We can combine these two terms, a minus 1 multiplied by e power j omega the whole power n. When you are expanding this, minus, when n equal to 1, we will get a power minus 1 e power j omega. When n is equal to 2, we will get a power minus 1 e power j omega the whole square. Likewise up to infinity. In this step, we have taken a power minus 1 e power j omega outside. Now we can write this expression as minus a inverse e power j omega divided by this term can be written as 1 by 1 minus a inverse e power j omega. We can rewrite this expression as minus 1 by a into e power minus j omega minus 1, which can also be written as 1 by 1 minus a into e power j omega. So the discrete time Fourier transform of this signal minus a power n u of minus n minus 1, which will be equal to 1 by 1 minus a into e power minus j omega, or e power j omega divided by e power j omega minus a. Thank you for watching this video.